Okay, we previously explained Diffie-Hellman protocol, an example of a key exchange protocol. A different variation of Diffie-Hellman is Diffie-Hellman elliptic curve, which is considered more secure. I may explain it in a different video in the future. So for now, I want to explain why exactly do we need key exchange algorithms in TLS. What is our end goal here? What are we trying to accomplish? Well, our end goal is to have the client and the server, say JP and YouTube, use encryption when communicating. You might think that we could have them use asymmetric key encryption. Actually, it's a bad idea. Let's visualize it. So, in asymmetric key encryption, each of YouTube and JP will have its own public private key pair. JP would send his public key to the server, YouTube, and YouTube also would send his public key to JP, and the respective private keys are kept secret. And then, if JP wants to send a message to YouTube, he will encrypt the message using the public key of YouTube and send it to YouTube. In this case, it will not matter if a malicious shady intercepts the message because, well, only YouTube can decrypt the message and make sense of it using its secret private key. Also, of course, the same will apply for YouTube. YouTube in this case would apply JP's public key to encrypt the message and send it to JP. On the other hand, only JP would be able to decrypt the message sent by YouTube using his own private key. So this is asymmetric or public key encryption, and it could work. So why the people behind TLS did not use it? Why instead use the other type of encryption, which is the symmetric key encryption? Well, the reason is very simple. Compared to the more simplistic symmetric key encryption, which relies on a single key for both encryption and decryption, asymmetric key is way slower and it requires more computation. A symmetric key encryption, it takes like nanoseconds per operation, while the asymmetric key encryption, on the other hand, can take microseconds to milliseconds per operation. In bulk encryption, imagine, for example, a typical visit to YouTube. Well, it will consist of many requests and response. So imagine all of these requests and responses using asymmetric key encryption. This will hit our performance compared to symmetric key. And one more important thing to note, security is still the same because symmetric key encryption is as secure as asymmetric key encryption. Okay, so now I assume you are convinced why we need symmetric key encryption. But, well, of course, now new challenges will arise. So, first of all, how can the server and the client negotiate and decide on a public key? Also, when decided, how can the public key be exchanged securely without a malicious shady intercepting it? Again, we explained in our previous video key exchange algorithms such as Diffie-Hellman. With these algorithms, a shared secret key will be computed on JP's side and on YouTube's side. Then, the shared secret key will be fed to the key derivation function, which will output for us many keys, including the key which will be used for the symmetric data encryption.